In this problem, we are going to go through loop balance, which is a problem under greedy section of algorithm on Hackerrank. So in this problem, we receive as input an array of log and an array of an indicator of the importance of context. And you're supposed to find out how can you maximize your log, because in this scenario we are in a situation where if you maximize your log, you will be able to win the actual context. So during the practice, how can you organize yourself to maximize your log? And strangely here, whenever you lose a practice test, it actually increases your chances of winning the context. So just that condition at the beginning, we just say, hey, if I want to win the context, I should lose everything. So if I lose everything, I will maximize the log, which will actually be the sum of the array of the logs, right? If you think about that, you are right. But you have another condition saying that you shouldn't lose no more than k important context. You do agree with that? If I lost everything, and then if I have more than k important context into the in the sum of my context, eventually I will end up breaking this condition. So you should also take this condition in consideration. So now that we have the second condition, how can we organize ourselves to have it done the proper way? So to have it done the proper way, what you can do is you can start by sorting the array descending based on the log. That means these are the contexts that bring you the most important log. And then why am I sorting descending? I'm sorting descending because I want to make sure that I'm losing the important context that will increase my chance of winning the actual competition. So whenever I will lose an important context, I will increment an indicator that will say, okay, I've already lost this number of important contexts. And then the end of the day, I will make use of it to see if I can allow myself, in fact, if I'm in a situation where I can still lose important context. If I cannot lose important context anymore, then I will be winning the important context. So that will be the idea. So for us to implement the idea, we are going to start by sorting the vector based on the importance of the context, and from that, after that, we are going to create an indicator starting at 0, denoting the number of important contexts we have been losing so far. And while moving, if a context, in fact, if the number of important contexts is actually less than this target, or if the context is not important, eventually I will lose it. I will just lose the context. And then elsewise I will win the context. So that will be our approach of solving this. So what will it look like? The first thing is, like we said, we want to sort the context. So is a sort that we already know. Oh, then. So I have the sort. Now since I want to sort descending, I need to pass a second parameter denoting how I want it to sort. Each of the element of the context is actually vector, so I need to put it this way. I'll say left here. Right here. And then what I should do is that I should return. What am I supposed to return? I want to make it decreasing based on the first element, which is actually the log. So just returning this. This is saying that compare the vector based on the first element of the vectors, and then consider an element big. If I consider an element to be placed before if that element is actually greater than the other, so we just sort it descending. By doing so, I'm sure that I have my array being sort descending. Now, what am I supposed to do? I should just have an answer which I will initiate at 0 and an important one which I will initiate also at 0. Now I need to loop through the array of context. So I'll just say for each of the elements, I just need to check if the important context is actually less than k, or if the context is not important. A context is not important if the second value of the content is actually 0. If the context is not important, or if I haven't reached the number of important contexts, I will just say the ans will be equal to the value of this, which is actually the value at position 0. Else I will just lose the context. In fact, else I will win the context. And winning the context actually reduce me the number of reduce my value. That's why I have the minus here. And at the end of each iteration, I need to check if the context is actually important. That means if the context is actually if context of e of 1 is actually equal to 1, that means the context is important. I need to increment the value of important. And at the end here, don't forget to return your arms. So basically, this is what you were seeing at its implementation. You sort the vector first to make sure that you have like the most important, like the content with the highest value at the beginning of the array. Once it had been sorted, now you have this. This is really important because it will keep the sum of the element while looping. This will keep track of the number of important contexts you've lost so far. If you've lost already the number of allow, in fact the threshold of the allow context, then you shouldn't miss anymore, right? So it is important for you to lose the important context with the highest value, because they are the one giving you the most, in fact they are the one actually maximizing your lock. So if you're doing so, you can allow yourself to win the order with less value. So by doing so, you're sure that okay, this condition is actually the condition helping us to do that, and then otherwise you actually win the context. And for each of the context you are going through, if the context is actually an important context, you increment this because it's going to be used here for the next iteration. So let us submit and see what it gives. We have a congratulations, everything is green. So this is my approach of solving this. I hope you do enjoy it. Feel free to leave me a message in the comment section. I'll be really happy to interact with you regarding this. See you in the next video. Ciao.